The sixth concept of regenerative farming systems is that insects are nature's garbage collectors. This is a concept that was pioneered by Philip Callahan when he was doing research for the University of, at the University of Florida, Gainesville, for the military years ago. He did a great deal of research on plant-insect communication systems and how plants and insects communicate back and forth. And essentially what he discovered was that when we look at healthy plants that are growing in the field, plants that are vigorous, dark green, no disease or insect pressure, plants that are truly healthy, this is what we see when we look at that field. And this is what insects see. Exactly nothing. If, however, we have plants that are unhealthy and we have insect problems in the fields, they have high levels of soluble nitrates and ammonia and soluble amino acids in the plant sap, food sources that those insects need to thrive and proliferate, then what we see in the field is we see plants that appear to be healthy. They're dark green, they're growing well, but they have insect pests. So this is what we see, and this is what insects see. Essentially, what Philip Callahan discovered in his research was that plants and insects communicate in the infrared spectrum. And in the infrared spectrum, unhealthy plants that have high levels of nitrates, ammonia, soluble amino acids in the plant sap show up in the infrared spectrum that insects communicate as a neon light against a dark background. They can see unhealthy plants for very long distances. So this is actually the bottom of a tomato leaf at 4,000 times magnification. All of these very small antennae are photon receptors that are vibrating in the very high frequency range of 26 to 36,000 megahertz. They're also photon receptors, and they are one of the mechanisms that plants use to communicate with their environment. So this is an antenna that we actually call, guess what? An antenna. Insect antenna that communicate. They differ from these antennae only in their effectiveness, but also in the wavelength that they are intended to receive, where the much smaller micrometer range antennae are intended to pick up much shorter wavelengths. This is what insect antennae look like. Some insect antennae look like when they're magnified underneath the microscope, and when you take one of those antennae and magnify it even more, you have even greater levels of magnification and smaller antennae, almost in the there's smaller and fragmentation as you go down. So these are effectively biological waveguides, and these biological waveguides are so effective. They are coated with a waxy dielectric coating, and there are no man-made antennae sensitive enough to pick up the signals and not only the infrared signals but also the pheromones that these antennae can pick up. And so this is the most effective way that when we see that plants and insects can communicate with each other. Really, this is nature's mechanism for survival of the fittest. The insects are there to take the unhealthy plants out of the system before they can be consumed as a food source by people.